Now let's take another example, example number 3, which is a little bit different. Now, in this side here, okay, when you're trying to simplify these questions, you can check both of them. Maybe sometimes the question is manipulating the student, which means how to identify which one is less complicated. Is this side here less complicated or this side here less complicated? So which one should I work with? Actually, sometimes some questions you don't have to, for example, to argue with yourself or to waste time picking which one is the best or which one is the difficult. Always when you see, for example, a fraction, okay, it's most likely will be the most difficult part, because a fraction, it's always difficult for all type of students. So always you take the side that has or contain a fraction. So sine beta over 1 minus cosine beta. So let's do it now. So let's take it here inside. Sine beta over 1 minus cosine beta. Let's start solving. Now, if you remember, I explained before something called conjugate. So do you know that what's the meaning of the conjugate? So conjugate, okay, means when you have anything over, for example, 2 minus 3x, okay, when you have something similar to this, how we can solve this one? So you look to the denominator, you multiply it again with the numerator, and you multiply it again with itself. So it will be 2 minus 3x and 2 minus 3x. But because we call it conjugate, we switch the sign. Always switch the sign. If it's negative, it becomes positive. If it's positive, it becomes negative. What sign that I'm talking about? I'm talking about the sign here in the middle. So check this one. If this one negative and this one negative, because the question is negative, so when I do the conjugate, you need to change the negative and you have to make it as a positive. So it's always like this. So now let's do this question here below. Okay, which is, now the denominator 1 minus cosine x. So I have to multiply the numerator with 1 plus cosine beta over 1 plus cosine beta. Okay, so now let's multiply everything together. So it will be sine beta multiplied with 1 plus cosine beta over, now check the denominator. Is this one difference of 2 square? Yes, because the bracket are repeated but with different signs. So that's why it's a difference of 2 square. So we can write it 1 minus cosine square beta. Now, after we identify the 1 cosine square beta, the next step will be how we can use the identities that we know, which is the Pythagorean identity. Do you know that 1 minus cosine x or square is equal the same as sine squared x? So I can replace, okay, 1 minus cosine, I can replace it with what? With the sine x? Yes. So can I replace the denominator with sine squared x? Yes. So sine beta 1 plus cosine beta. So all of that is over what? It's over sine square beta. Okay? Now let me continue here for you. Okay? So now sine square beta can be cancelled with a sine, because it will be sine beta times 1 plus cosine beta over sine beta times sine beta, because sine beta times sine beta means what? Sine square. So now can I cancel? Yes, I can cancel this with this. It means 1 plus cosine beta over sine beta. Now, as you know, if I need to simplify this one more, we are doing the hard way. What's the hard way? Which is 1 over sine beta, 1 over sine beta, and cosine over sine beta plus cosine beta over sine beta. Now we know that 1 over sine beta is cosecant beta. Is that right? Right. Cosine beta over sine beta, this one is what? It's cotangent beta. So now check this one. Is this one similar to this one? Yes, so this is the final answer. Now try to solve this to question number 3 on the blue one. If you need help, please let me know. Now, one of the other example, okay, of solving, oh, sorry, this is the same example that we did previous. It's the same, but this is the book way. It's the same idea, just the book sometimes is skipping some steps, which is fine. Now, let's verify that this question here. As you can see, it's for similar this question, it's easy to know which side is to pick, because you know that the big side is always the complicated side. So check this one. So all of this is the big side, which is the most difficult one. Now, similar this question when you have no fraction, which is you can't multiply to make common denominator, or you can't use the Pythagorean identity. Here, sometimes you can do factoring, which is you take the common factor. Like for example, if we have x squared plus 2x, how we can solve this? We can take x as a common factor, so it will be x plus 2. So the same idea works here. Now look to the part here, before the negative. Before the negative, I have secant, okay, and I have cotangent. After the negative, I have cotangent 3 times, and I have a secant. So can I take secant and cotangent as a common factor? Yes. So when I take the secant and the cotangent from here, it remains what? Cosecant square. When I take the secant and one of the cotangent, it will be cotangent square. Now we know that cosecant square theta minus cotangent square theta, this 2 is equal what? Is equal 1. So I can replace both of them, and I can write what? I can write 1. So I can replace all of this part and type times 1. And because this one is times 1, so 1 is removed, because anything times 1 stays itself. Okay? Now, as you can see, the cotangent is cosine over sine, right? So I can replace cotangent. As you can see, cotangent can be replaced with cosine over sine. Secant, what's the rule of the secant? It's the reciprocal of 1 over cosine. So 1 over cosine. Now, can we cross the cosine? We can cross this with this. So it remains 1 over sine. 1 over sine is the reciprocal for the cosecant. So cosecant is the answer. So I verified it. Now try to solve these 2 questions by yourself. It's an easy question, same idea, which is using the factoring. Now, let's go to the last part of the lesson. Here, okay, I forget to hide the answer, but it's fine. Okay, you know the idea. Now, let's verify this question here. To verify, sometimes read here, verify an identity by working on each side separately, which means each side separately. Some questions similar to this, I told you before the beginning, you need to pick the complicated side to work with. And as you can see, the left side is a fraction, it's complicated. And you can see the left side also complicated, which is difficult. So now what should you do? Now, when you're trying to simplify, you don't have to simplify, which is until you reach a small thing. No. Now, when you're trying to simplify, for example, you simplify the first step, you simplify the second step, simplify, for example, third step, then stop here. You don't have to simplify it. Okay? Then after that, you take the right side, you simplify, you stop here. You will identify, or you will recognize that, you will realize this one here is equal to this one. So we can stop here from the right side, from the right side and from the left side to reach to the same answer. So for example, look to this one here. So in this question, I took tan square x over 1 secant. I took this side here, or the left side. So now I know that tan square x is the same meaning of secant x minus 1. So I can replace tangent, with what? With secant square x, as you can see here. So I replace tangent this. Now after this, 1 plus secant stays same. Then this one here, when you have, let me write it here. So secant square x minus 1, can be written as difference of 2 squares. So secant x minus 1, secant x plus 1. So this is what you can see here. Then after that, I can cancel the secant plus 1 with 1 secant. So now I reach this step. Now check this one. Is this one similar to this one? No, it's not same. But I will stop here. I will never continue. Why? I am going now, sorry, let me erase this. Okay. I'm going now to take this part here and write it down and simplify it with the same idea. Okay? When I'm simplifying, my goal is to reach to the same of this one. When I reach to the same of this one, I finish. So let's simplify this. So now we can do, to simplify this, 1 over cosine, so 1 over cosine x, minus cosine over cosine, minus cosine x over cosine x. Now let's simplify this. 1 over cosine, this one here, is the same idea of the secant x, because they're reciprocal. Cosine over cosine is equal, what? 1. So do you see here? I reach to the same one, okay, on the right side. So now from here and here, both of them are reaching the same answer. So this will be your final answer. Okay, so that's why you need to work on each side separately. You work on the left side, reach two steps similar to this. Then you start work on the right side, then until you reach to the same step you reach to the first one. If you reach the step here, different than the step here, so you need to still more do simplifying and also more do simplifying until you reach to step that both of them are equal. Okay, then you stop there. Now, let's do the second question. Okay, let me put this one here and let's do it together. So the first one, let's take the right side here. Okay, tan x plus 1 over tan x. Okay, so now let's make the hard way. So tan x, so tan x over tan x plus 1 over tan x, 1 over tan x. So now tan x over tan x is equal 1 plus 1 over tan x, which is equal 1 plus cotangent x. So now let's stop here. So this one should be the answer. Now, using the other side, let's simplify it. It will take maybe a long time for us, but it's easy. Cosecant square x over 1 minus cotangent x. Now, cosecant square x, this one can be replaced by cotangent square. So for example, cosecant square x is equal cotangent square plus 1. So this one here. So now I can replace all of that with what? With this here. So now let's replace it. 2 minus cotangent square x plus 1 over 1 minus cotangent x. Now let's simplify this. It will be 2. We distribute the negative for both of them. So 2 minus cotangent square minus 1. So all of that 1 over cotangent x. Okay. Then now, sorry, let's remove this. Okay. So now let's add the like term. I have here 2. I have here negative 1. 2 minus 1 is equal 1. So 1 minus cotangent square x over 1 minus cotangent x. Now you know that the numerator is difference of 2 square. So it will be 1 minus cotangent x times 1 plus cotangent x. So all of that is over 1 minus cotangent x. So now let's cancel the like term. So this one, cancel this, remain 1 plus cotangent x. So do you see now both of them reaching to the same? So this is how we can verify from both sides. Now try to solve question number 5, but already the answer there. If you have any question, please let me know. Now here, if you read them, I summarized all of them, the strategies of verifying. Let me tell you something about verifying. Verifying, my student, is not a way or rule that you need to memorize. It's, for example, it's the way that you need to follow while you're simplifying. You need to use everything, identities, or for example, the reciprocals, Pythagorean identity, to be able to solve it. So if you read here, it will help you or to guide you. Always you need to memorize the reciprocal. For example, what's the reciprocal for sine? What's the reciprocal for the cosine? What's the reciprocal for tangent? Okay, and also tangent has another thing, which is cosine x over sine x. You need to memorize all of this. And here 1 over cotangent x. Here it's 1 over secant x. Here it's 1 over cosecant x. So, and the opposite also is true. Cosecant x, secant x, also cotangent x. We have also another cotangent x, which is equal, sorry, sorry, I need to flip this. So this one, it should be sine x over cosine x. So the reciprocal will be cosine x over the sine x. So all of these, you have to memorize them very well because you are going to use them while you're solving the question. And if you memorize them, if you practice more, you will be able and easy for you to be simplified. Also, we have the Pythagorean identity, which is example sine square plus cosine square x is equal 1. Okay? And every time you divide by something, for example, if you divide by the sine, you divide by the sine, then you divide by the sine. It's similar what I told you, sorry, by sine square, sine square, sine square. So it's always when you do this, you can get, for example, 1 plus cosine square over, which is cotangent square, equal 1 over sine, which is equal cosecant. So cosecant square x. So this is one of the theory. And also there is another theory, which is when you're dividing by cosine. So all of these identities, you need to know how to deal with them, because if you know how to deal with them, you practice and you memorize them, all the question verifying will be easy to you. Okay? I hope you understand. This is the end of the lesson. I wish you the best. Congratulations for Thamir International School in Saudi Arabia. And congratulations for the graduation, girls. Okay? Have a good day. See you. Bye-bye.